Okay, let's start out drawing a picture. So a ship sails due east, so that means if we have our compass, it is going straight to the east for 72 kilometers. And then it gets pushed off course for 20 kilometers at a bearing of north 32 degrees east. So we draw ourselves a new compass, and we do north 32 degrees to the east, and then it is being pushed 20 kilometers off course. Now, when you read this, you could also technically draw this as the ship is going due east for 72, but this other vector is pushing it at this 20 kilometers off course at the north 32 degrees east. And then your resultant would be, well, the ship is going to be somewhere in between those vectors. That doesn't really give us a good triangle to go with, so that's why I like doing the full ship vector, and then we put the current at the end of that vector, like what we did down here, because then we know the resultant goes from beginning to the end. So our goal is to find the magnitude and bearing of that resultant. The magnitude is just its length. The bearing means we want to find out what is the angle the ship is actually going. So first we'll do the magnitude, that's the length of that. And we have side angle, we need to find that side here. So we can use law of cosines. Keep in mind we have our compass, we know that's 90 degrees, which means that full angle is 90 plus 32, which is 122 degrees. So we know our magnitude then. We'll use the law of cosines, so magnitude squared will be 72 squared plus 20 squared minus 2, 72, 20, cosine 122. So let's type that in a calculator. And that gives us, before the square root, 7,110.17. Take the square root because that was magnitude squared. And we get that our magnitude is 84.32 kilometers. So we know even though the ship took off to only sail 72 kilometers, the current helped push it further, so it actually went 84.32 kilometers. Now the second part of the question asks what is the bearing, meaning from that starting point, what is the angle the ship actually ended up at? So we need the outside angle, but to find that, we can find this inside angle here. And we have enough information now, we can use our simple law of sine. So we can set up 20 over sine of the angle we're looking for, I'll just call it theta, equals, and then with that resultant, we have an opposite, so 84.32 over sine of 122. So we cross multiply, 84.32 sine theta equals 20 sine of 122. Divide the 84.32 over, and then we'll have to take inverse sine of that to find the angle. So we type that in a calculator, and we get 11.60. So again, that's the angle inside the triangle. So now to get the bearing, again, it's a compass, so it adds up to 90. Just subtract from 90, and we'll do 90 minus 11.60 gives us 78.4. So the bearing of this would be starting from the north, it's going 78.4 to the east. So north, 78.4 degrees east. Hopefully that helped remind you kind of how bearing works, and I've spent a bit. But really it's just going back to law of sines and law of cosines and working around that compass. So hopefully that helped.